Okay, chapter 2.9 is problem solving. Problem solving, it means that means story problems, guys. I hate to tell you this. Uh, Story problems. And many people are afraid of story problems. And they are kind of tough. They take a lot more time, but usually you have fewer of them to do. Okay, you might have 35 long division problems, but only 5 story problems. If that makes sense, you could choose which one you want to do. All right, we're going to just kind of walk through it. I'm looking at page 95 on the book. In the book, you don't have to look there, but you can. Sean and his family chartered a fishing boat. That means they bought it for the day. They paid money to go fishing. And Sean caught a blue marlin and an amberjack. So he caught a blue marlin and he caught an amberjack. I don't actually know what an amberjack is. The weight of the blue marlin was 12 times as great as the weight of the amberjack. So the blue marlin was 12 times as heavy as the amberjack. Let's spell that right. Okay, 12 times as heavy. The blue marlin was 12 times as heavy as the amberjack. Okay? Okay, we got that much information. The combined weight of both fish was 273 pounds. So if you combine them, the blue marlin plus the amberjack equals 273 pounds. And I'm just saying this B stands for the blue marlin and the A stands for the amberjack. It's kind of cool because amber is a color and so is blue. Kind of neat how they did that. Okay, so this one is 10 times as heavy as this one. So basically this is algebra. You have to be able to write what the blue marlin is compared to the amberjack. Okay, so we might say that it takes that this one, the blue marlin, is 12 times as heavy as the amberjack. So if I were to split it out, the blue marlin would be the same as 10 amberjacks. It would be kind of like saying A plus A plus A plus A plus A, there's 5, plus A plus A plus A plus A plus A, there's 10. These 10 amberjacks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 amberjacks would be the same weight as one blue marlin. Oh, but it doesn't say 10, it says 12, so I need to add 2 more. Whoops. What color was I using? Plus A plus A. So we're going to say there's 12 of them. All right, do you see that? Okay, so there are 12 times. There's 12 amberjacks are the same as one blue marlin. 12 A's are the same as the blue marlin. Does that make sense? I hope it does. It's a little bit confusing. It's kind of like algebra, but we're just going to swap this out. If I had all these 12 A's and I changed them out with the blue marlin and I kept the amberjack that I already have, how many total A's would I have? I would have 13 A's because I've got 12 A's that equals the blue marlin plus the 1 A that I actually caught, the 1 amberjack that I actually caught, and it all together equals 273 pounds. LBS stands for pounds. Okay? Does that kind of make sense? So really, what I have, I could pretend that I could say, well, the weight of 13 amberjacks is equal to 273 pounds. Now, I'm saying 13, but I want to know how much each fish weighed. So I really need to find out what one amberjack weighs, and then I can figure out what my blue marlin weighs. Okay, so if it takes 13 amberjacks to make 273 pounds, that's the same as a blue marlin plus an amberjack. since a blue marlin is 12 times as heavy. I know I've said that 7 times, but I want you to make sure you understand. This is a multiplication problem. This is 13 times the amberjack equals 273. And since it's a multiplication problem, we can do a division problem. I can do a division problem to figure out what A is. See, 13 times A equals 273. That means that 273 divided by 13 has to equal A. Okay, because division is just backwards multiplication. Just like 15 divided by 3 equals 5, and if I do it backwards, 5 times 3 equals 15. Either way, it works. They go forward and backwards of each other. So I'm changing this multiplication problem into a division problem. That means I have to figure out how many times 13 goes into 273. And I'm going to do everything I've been taught to do this last week of long division, the last week or two. I'm going to estimate this. I'm going to round this down to 10 and say, well, how many times does 10 go into, we'll say the compatible number would be 300. And the answer would be 30 times. 30 times 10 is 300. So we're going to try putting a 3 in and see what we get. I think we're going to get a big number because I actually already know what the answer to this is. It's too big. We need to do 2. 3 times 13 is 39, and we only have 27. So we're going to back that right out. We did that too big. We needed to do something different. Maybe go down to 20, 200 instead, and that would give us 20. Might be a better way to compatible numberize this one. Okay, so 2 goes into 13, and let's just go ahead and change it again. 2 times 3 is 6. 2 times 1 is 2. So 27, take away 26 is 1. Bring down the 3. How many times does 13 go into 13? I'm glad it comes out evenly. It goes in 1 time. 1 times 13 is 13. So we have no remainder. Okay, so that means that our A, our amberjack equals 13 pounds. So if our amberjack is 13 pounds, and we know that the blue marlin is 12 times as heavy, I could do 12 times 13 to figure out what the blue marlin is, or I could take my total, 273 pounds, and subtract 13 and see if that works out. Let's do that over here on the side. I'm going to get math all over this page, you guys. Sorry about that. 273 minus 13, because 13 pounds is what the amberjack weighs, equals 260 pounds. So 260 plus 13 does equal 273, and we know that our total weight is 273 pounds. Okay, now the nice thing would be to check to see if 13, since the blue marlin weighs 12 times as much as the amberjack, let's check to see if 13 times 12 is actually 260. It should be. 3 times 2 is 6. 2 times 1 is 2. Bring down my 0. 1 times 3 is 3. 1 times 1 is 1. Add those up. I'm running out of room. 6 plus 0 is 6. 2 plus 3 is 5. And 156. That didn't work. What did I do wrong? 2 times 3 is 6. 2 times 1 is 2. 1 times 3 is 3. 1 times 1 is 1. 156. So something didn't work out. 213A is equal to 273 pounds. Divide 21 times 13. Aha. It's not. Where did I get this 13 from? Look at that. I grabbed 13 out of here. It's not 13, it's 21. Will you guys forgive me? I might have to start this all over because I put down 13. It's not 13, it's 21. It's nice to see Here, let me explain. I checked it once this way and it worked, and then I checked it this way and it didn't work. So by checking it twice, I caught my ginormous mistake, and we're going to have to just do some quick erasing and do those numbers again just for you so that you're not confused. And you'll see right away that we were right. It's 21. Somehow I grabbed this 13. My brain saw that 13 and grabbed it, and the quotient's really 21. The quotient is 21. So if we take 273, like we did, 273, and I subtract 21 pounds from it, which is the weight of the amberjack, then I get 252. Now 252 should be what 21 times 13 is. 21 times 12, because this is 12 times as heavy. The blue martin is 12 times as heavy as the amberjack. So that's it. 21 times 12 should also give me the same number. 2 times 2 is 4. 1 and 2. And how could I run out of room? Gonna have to. This is one of the craziest math classes you guys have ever had to sit through. Especially if you're home watching with your parents on the iTV. Try it up here. This is just a lot of math. 21 times 12. One more time. Because the blue marlin is 12 times as heavy as the amberjack, that means it's 12 times the weight of the amberjack, which is 21. So 21 times 12. There's 2 times 1, and 2 times 2 is 4. 1 times 1, and 1 times 2, and then 2 plus 0. That matches. 4 plus 1 is 5, and that matches. And the 2 is 252. It matches. So I've gotten 2 answers that prove I was right. Okay, now, if this isn't a lot of math, do you feel like you're in calculus class? Do you feel like you're in college algebra, college math? Well, that's partly why I thought maybe we'd do this together on the video, because we're probably going to have to do this again in class tomorrow, but this gets us a good start. Let's look at page 96. They say try another problem. Everything in here is about fishing. Interesting. Fishing. Jason, Murray, and Dana went fishing. Dana caught a red snapper. Jimmy caught a tuna with a weight 3 times as great as the red snapper. So we got to put our information down here. Jason, Murray, and Dana. Okay, I'll make a little chart. Jason, Dana caught a red snapper. So I'll put this right in here. Dana caught a red snapper. Jason caught a tuna. And it weighed 3 times as much. So it would take 3 red snappers to equal the weight of the tuna. Does that make sense? Because the tuna weighed 3 times as much as the red snapper. Murray caught a sailfish. With a weight 12 times as great as the red snapper. So it would take 12 red snappers to make a sailfish. Okay? So, let's see. It would take 12 red snappers to make a sailfish. So this 3 times as many red snappers to make a tuna, and 12 times as many red snappers to make a sailfish. Hopefully that sort of makes sense. Trying to get our information listed here. If the combined weight of the 3 fish was 208 pounds, how much did the tuna weigh? So we have the tuna, the sailfish, and the red snapper all combined. The tuna plus the sailfish plus the red snapper equals 208 pounds. How much did the tuna weigh? Now, the only thing we know is that the red snapper weighed 3 times, or that the tuna weighed 3 times as much as a red snapper. Okay, so remember what we did at the last problem. We have to do the same thing. We have to put everything in terms of our red snapper. Okay, our red snapper is the important one. It weighs 3 times as much as a tuna weighs 3 times as much as a red snapper, so it would take 3 red snappers to make a tuna. Kind of think of it like this, like parentheses. And how many red snappers does it make to make a sailfish? Well, 12. 12 red snappers. They're really making me draw a lot of R's here. This is slightly different than we did it on the other page, but I think maybe it'll make more sense. You can see what we're doing here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that's the 12 red snappers. Because a sailfish weighs 12 times as much as a red snapper, it would take 12 of these red snappers to equal the sailfish, plus the one solitary red snapper. And all of those equal 208 pounds. Okay, so if we changed our tuna into 3 red snappers, and we changed our sailfish into 12 red snappers, and we left our other red snapper alone, how many red snappers would we have? Well, we'd have 3 plus 12 plus 1 red snappers. So that's 12, 13, 14, 15. That's 16 red snappers equals 208. Okay? So if I'm going to clear this, you'll have to go back to it. You'll have to hit rewind, but we ran into too much trouble on the last page. 16 red snappers equals 208 pounds. Hopefully we won't have to go back to that. 16 red snappers equals 208 pounds. So 16 red snappers is basically the same as 16 times the number of red snappers equals 208, and that's a related division problem just like we did before. 208 divided by 16 equals the poundage, the weight of the red snapper. Does that make sense? Division is the opposite of multiplication. So we're going to do a division problem, 16 into 208. And we just have to realize that 16, this one actually you don't even have to estimate much. Does 16 go into 20? It goes 1 time. We know it can't fit twice, so we don't really have to do much with this one. We're not going to have to write a big estimation problem over here. But 1 times 6 is 6. Let's just make sure I change my color. 1 times 1 is 1, and then subtract. 20 take away 16 is 4. Bring down the 8. Now, here I might have to do a little guessing. If I rounded 16 down to 10, it would go in 5 times. If I rounded 16 up to 20, it would only go in 2 times. So 5 is my high estimate, 2 is my low estimate. So we're going to just have to guess and say 4 and see if it works. I don't think it's going to work. I think we need to use 3. But I'm going to go ahead and try it because we went ahead and we wrote it out here. 4 times 6 is 24. 4 times 1 is 4 plus 2 is 6. Yeah, that's too many. If we go back and try a 3, 3 times 6 is 18, and 3 times 1 is 3 plus 1 is 4. 48 comes out easily. So 13 is how much our red snapper weighs. Now if you'll remember from the problem, it said that a tuna weighs 3 times as much as a red snapper, and they wanted to know, that's the actual question, is how much did the tuna weigh? So the tuna weighed 3, the red snapper is 13 pounds. So the tuna is 13 times 3, which is 39. Okay, so the tuna weighs 39 pounds. Okay, how did that look? Was that a little easier? Okay, so those are our 2 practice problems. You have to do a few on your own. We'll do a couple more in class. hopefully you've already filled out your book a little bit just using this sample problem. And you know what? I feel like I'm taking up a lot of your time. So you may watch the video. Sorry, you may watch the what's happening here. My computer won't. Ooh, maybe it's because I'm almost out of battery. Um, you may or may not want to watch me draw another picture. Um, let's see. Let's since it's coming up towards winter, we'll draw a guy. Maybe we should draw a girl this time. I don't know if I know how to draw a girl. Here's a girl. Everybody has a peanut-shaped head. And since she's a very beautiful girl, she must have really big eyes. And she must have long, flowing hair. And maybe she has blonde highlights. I don't know if those show up very well. And she's got these pretty bangs that hang down in front. And hopefully it covers up her peanut-shaped head if we get enough hair on there. You can't even see her ears. Maybe the ears need to be in there first before you get the hair all drawn on there. Yeah. And she's got a very happy smile, kind of a quirky little smile, and a button nose. That's right. And what is she doing? You guessed it. She is headed down the mountain on a pair of skis. And she's got her poles out here, and she really knows what she's doing. She's ready to hit the powder. Woohoo, she says. Fun. Okay, look forward to skiing with you later. Have a good day.